Okay, fine. So, good evening. Koi kena tauba ngarang si potential energy ki concept kara tauba hogre. Aduna ngarang ida fat lau na quick recap ama satsi. So, koi na ngarang tauba du potential energy ki ka quick recap ang yes silere. Potential energy haibasi kay na habda ka kedoba. Restoring force haidi quite first the potential energy like haragadi stable equilibrium dagi podamazi koina kedoba displaced tokpa matamda restoring force amana which is conservative in nature ka aduduna mazi amuka ziki stable equilibrium du the purak kaduineba aduna adugi against abdi koina thaba ama tawba habdi pose displaced tokthogadi stable equilibrium dai bu displaced tokthogadi potential energy lakani ba ka adu natabida stable equilibrium again stable equilibrium si conservative force leitragadi stable equilibrium su kedoba leiroiba ko ona si myam si loinamak mari leinai conservative force equilibrium the stable loiba restoring force then negative of work done all these are very important ka adu sing do khangadamne still noi the conservative force si doubt leiba mi yargadi haipetang telapna amtanga hange conservative force haragadi haziki force in work done tawba matamda magi path da depend tawdaba initial and final position da khatang depend tawba ka adu du khina kai kawi have the conservative force kawe ba ka aduna yam tuna ka for example let's say aduna sigi point A zidaina sigi point B zibo satpa matamda part 1 part 2 and so into part 3 and part 4 kind of see part 1 this is part 2 this is part 3 this is part 4 if the force is conservative the w1 is equal to w2 is equal to w3 is equal to w4 so having nang path to kari path the nang object to displace to no id kedoba magi initial position then final position bowa then displace to which path you take doesn't matter it only the work done depends only on the initial and final positions so aduduni conservative force I see only initial position and final position the khatang depend the path that depend the so aduna bu conservative force ki depend definition ji kai hai path kai hai independent force path independent force adumaina hai then equilibrium makalani lay stable unstable in highest energy ni stable in lowest energy ni so main lay then si question ji koi ngarang solve to gre so ngasi gi tawrasi ngasi gi sida koina ngasi gi tawrasi so nei ngarang question number 37 tawre question number 38 sidi noi dum ngamgadra try tawraba hainaro sunanda adagi lakshmi haro kingshan haro
Sangamani.
Ngamani question number 38 ngamani buka Lakshmi ga sunanda ga di
Ngamani sir I first hold crazy questions
okay Lakshmi di
What is it?
Peba Lakshmi hot seba
Not it. What? Oh, yarni.
Yarni buka hot kre buka okay fine so question number 39 jidi the massive was in a vertical circle okay fine so vertical circle have si yung tak to di aroy vertical circular motion tak to di aroy potential energy of a spring okay fine so sige sima topic mo sam ta ke vertical circular motion na vertical circular motion yamna like the kemta kenato ninga yaude it's just conservation of kedoba mechanical energy again do kenone noida di kenato udangai conservation of mechanical energy see adu hanta katra application of conservation of mechanical energy oigadane aduna adu hana takana di fagadibuka so all right let's see Ko. Conservation of mechanical energy. Now, mechanical energy is equal to Kangbra. Kaya to ko Kingshan adagi Lakshmi Sunanda noi marakta mechanical energy si kaino khangba mi yaubra.
Sir, potential energy ka kinetic energy ka ani.
Very good, very good. Mechanical energy are the sum total of abdicatoba potential energy ka. Potential energy and kinetic energy. Very nice. Now, conservation of mechanical energy na ma law malay adudu kaino khangba mi yaubra. Conservation of mechanical energy.
Work done of conservative force plus work done of non-conservative force are equal to change in kinetic energy plus minus plus change in potential energy or answer.
Okay. Okay. Kingshan ni definition high grade ka. Sunanda khangbra. Lakshmi khangbra.
Sir, sum of the potential energy to ka kinetic energy ka at any time the level is constant oi.
Oi du si kam kan no. Haidi kai do bai oi du no kam kan oi du no ba.
Sir, external force yaudra the.
Okay, Sunanda definition high re. Lakshmi haro. Lakshmi try to ro. Khangde ka. Okay, fine. Keno to ba. Asterisk su lai bra du da.
Laser.
Asterisk ta amuk high law conservation of mechanical energy si kaino na natraga magi phone dai changira no ni dum yaumina rakira ka. Asterisk haro conservation of mechanical energy di kaino. Still waiting. Haidi keno ni recorded session ni na yam kuin give lai roi si ka. Conservation of mechanical energy si kaino khangbra.
Hello, sir, tama sir.
Yes, yes, tai. Yes, haro. Haro,
Body
haro.
am the ecto first man body am the ecto do particle to do the conservative ko I did total mechanical energy concept to
Total ke do ba mechanical energy se conserve to ba. So total mechanical energy se karam kan da conserve to ge ba.
force garden
Force or gadi.
body am the force man na ecto matam the
Sir,
Haro.
force man conservative work and the body am the ecto force man do conservative work and the mechanical energy conserve work ne.
Okay, fine. All right, fine. Keno jo hining mo male. Sunanda hining mo male.
Masaya sir ay soy na high grade conservative force hay daw na sir. Time the depend of the at any point the sum of the potential energy ka kinetic energy kasi adum throughout its motion constant only.
Time the depend to the kari the depend to have the karam kan da no ba sum of potential energy and kinetic energy constant ho je karam kan da no ba.
Motion do object ki motion se laan ba matamda if conservative force na laan bo oy taragadi adumay kan sir.
Okay. Yeah. Kay ni
external force ay taba kanda hoy.
External force like kan da dinatte. Screen share to si yadrisi kay no. Strange. Oh, smile kan ko. Yeah. All right, fine. So, conservation of mechanical energy ki laws ina kay high have matam da ka if kay daw ba the forces acting on a body or system of particles say low in a conservative for gadi can diagram if kadoba if the okay force got if the net external force I get or if the force acting on a body or a system of particles are if the force acting on a body if the forces acting on a body or system of particles are all conservative loinam conservative force ngata oiba taragadi we don't have the kedova the total have the total mechanical energy of the have the okay of the body or system of particles is some repeat if the forces acting on a body or a system of particles are all conservative, the total mechanical energy remains constant. So now I have the total mechanical energy is again mechanical energy is the potential energy ka kinetic energy ka so sum total of the potential energy and kinetic energy or in other words total mechanical energy is a constant or conserved term kanda oigani habada if all the forces acting on the body or our system of particles if all the forces are conservative forcing the law in conservative non conservative force ama hek yaw mechanical energy total mechanical energy to conserve oiroyebako aduna we have matamda karum kanda conserve oiniba force to loine ma conservative for kanda gyan tai ko gyan tabra ta dabra
Yes, sir.
tai ko aduna we have for example let's say aina ko amuk mangre to is stops straight for example aina sigi sidagi kaigumba port amazi aina let's say kay hesiga mai ko for example sigi poche aina my ground dai sumain thagat pa matamda or sisi aina sumain to thadareba thadarakpasida kaidawi ha matamda sida lema potential energy si ida ta matam sida kinetic energy oina si sida yaiga doineba si lemda di tagi doine ma si lemda adum tagi doine ko aduna kaidone potential energy to kinetic energy the own grave but total energy the conserve potential energy handare but kinetic energy the sum ta kuma to yankalak pen hengalak ne velocity hengalak pen ko aduna haining I wazi kaino ha matamda potential energy handaraga su kinetic energy hengalak ni or aina si pochi matak su main langat pa matamda jadi sida velocity ma yam yang langat pa matam sum tapthara highest point di ma momentarily rest like ne on kinetic energy di sum tapthara last zero chakreba but adu the my potential energy maximum moiga doine ko aduna adu mayam si mayam possible or it's all because the gravity of the my weight gravitational force is the conservative force ne ko electrostatic force conservative force ni springy force conservative force ni but if we consider the viscosity or air drag air friction consider the water gadi adu gadi amuka conservative oira roeba gyan tai ko is sarna sarnaji gyan tai ko aduna force loinama conservative if all the forces are conservative then the total mechanical energy or the sum total of potential and kinetic energy remains constant mayam loin gyan ta obra
Sir.
we got okay fine so sunanda ta hai lakshmi asterisk kingston loin ta obra okay Lakshmi gi makon yam pi kang fikre okay I got just 1 second sound
Sir.
how yeah ta all right fine ya record dia tai ko so ako ejik adudi noi si gyan ta ngai ko keno to bo Lakshmi gyan tahoraba
tahore sir.
aduni Lakshmi nga sa habdo net external for 0 oi ba habdo adu natteba net external for 0 oi ba dudi kaygino habda conservation of linear momentum gineba ko conservation of linear momentum ga conservation of mechanical energy ga confusion na ganu ba ni ji mana deba ko linear momentum dadi net external force leitragadi linear momentum se dum conserve hoyeba ko aduga conservation of mechanical energy dana external force leiduni leiba external force conservative in nature oiba taragadi magi total mechanical energy and total kinetic energy do conserve hoy habeneba ko habadi that is haraga potential energy plus kinetic energy is equal to constant constant if all the forces are if f se kai oiragadi conservative oiragadi gyan tai ko yare ko se
Hoi sir.
okay fine now let's do vertical circular motion ko so keno to moigi kai secret application kulai sina yeke compass na to keno to nam do mani da ka mani come on okay so okay okay sorry yeah ka so now Zik let's do vertical circular motion ka munataro yeah now Zik kaido we have matam da aina vertical circular motion da magi ka kaido ba kai puthok sige habda magi tension nung puthok pe ai and then question gi makha pole ka my velocity nung ama ma puthok pe ai ka so anyway Hazik kaido we have the sigi my center sidaina sida mass amazi sidai da yantare ba ka okay now sida mass amne sipot sida aina kaido ba velocity ama u ama velocity p re ba initial velocity u ama p ba matamda masi kaido rak pa yai habda masi si tan chalasu yai or si tan chalasu yai or haidi mana chat pa yawa se kai bu chat pa si tan haidi si gi u ji ma tak lang push tok ba si bu chat pa si bu chat pa or si ji ma pull up round square swain tara ju yai ka adu bu kaido ye si bu yogra ga di compulsory magi kaido ba magi momentum duna hai gadra magi kaido ba inertial motion duna maram orga sigi vertical position jibu yordi swain leira tarane mas yan dai ko cha aduna aduga masi swain chala swain halak pe swain chala swain halak pe swain chala swain halak pe mayam position mayam chat pe ba ko aduga sibu yogra di dum swain to tarane now jig masi suppose let's say swai bu chala en khala zero yare ko adur gadi adur di ke do we have the ying si ko my tension nung khara putoksi auna magi free body diagram ma yek toksi ka the mz lere then let's say this is theta aduragadi masi kaina kedoniya matamda sida tension ji t lere and then sisi kayoni mz cos theta natra mani sida theta lere sida sudum theta lere ni ko and then sida na kaino mz sin theta lere ni gyan tabra ta dabra tai ko pau khona bra pau nei aduna yam lai to si ko kem to keno to ni lai ti aduna magi horokpa matam da ti position je initial and final ne ba ko aduna sigi vertical circular motion ji kaina the application of conservation of mechanical energy ka mechanical energy thongamba thingi kai gina
sir ai chak tok tangai ye sir
oh okay fine is equal to potential energy final plus kinetic energy final ka so c sineba koi conservation of mechanical energy as ka so potential energy final di kaino 0 kaino height kem raise to den lower ni plus kinetic energy di kaino half mu square le ni then potential energy find plus ire kaino equal to equal to potential energy final di kaino have the mg h ki mahuta ina r minus sarga r cos theta have yai now seeing ngor mani h kamain to r minus r cos theta line have ka so sorry explain to okay don't worry plus kaila kani have the half m haraga magi sum kedoba sida leiba magi velocity amadi layamni na ko v na ko aduduna half m v square and layer ne ko so now see r minus r cos theta z kamaina la ino have the square harake munna taw see circle zikka agadi okay fine see this my laidna ko auna si kaino ha matam da ko hajiki du da dum yengo sumai lei sai ti magi hanagi ko bob sigi hanagi magi position ji sida layer mane sida kakat kreba auna magi height si change kar layer habdi magi ke do yabda sigi chang se ma raise to reba sigi level je auna sigi total si ju r ne ko and then si ju total je kaino this is also r ne but sidena si pose kaino this is r cos theta natra se aduna yan da ko wat pra kaino ne sing se hadi sigi total sina r ne ko aduga sigi matek sina r cos theta ne ba aduna nuina kaidonia matam da sigi matek se height se magi height se h is equal to r minus r cos theta haiba yaroidra gyan tabre ong si se
ताई sir
tai ko mayam loin tai ko aduragadi kedo we have yes adudi kedo we have matamda m ka kre aduna aina kaigumba final velocity se pamagadi v square se pamagadi aina si asom sida ko into torne aduragadi u square le ko then minus sarga zr si aduga plus sarga zr cos theta so si 2 la kani ko 2zr and then 2zr cos theta na la ni v square se si gyan tabra ma'am
ताई सर
tai ko okay fine adun kayumba in a v square pam da b dang ira gana root over na ko adun har ci adun mai v square na dum thammage ko now magi zik tension putoke ko aduna aina muka kai khangi ha matamda m v square by r have the pot se circular motion the chalaga the centripetal force ama laitaba yaroi ko aduna aina centripetal force 2 m v square by r ni centripetal force t ko so cz kai ga manabam thoi have the t tension t minus mz cos theta ga manabam thoi ko aduna aduraga the v square is equal to or why don't I do like this tension putok ning mani na ko so t is equal to harga aina kedo we have the nasai si sida v square sida m by r na into to taraga di kai lakani have to ko adu ma yeng si so m se ko adu dum hap sira hapoisira v square ko t se okay fine yare so m by r irage aduga v square gi mota u square minus 2zr plus 2zr cos theta lere minus mz minus nante plus ne ko mz cos theta lere ko so durga di m by r u square minus harga 2mz plus harga r ka kre so 2mz cos theta ga mz cos theta ga di kai tarani 3mz cos theta so this is the value for tension ka aduna sisima kangadabani gyan tahudabra say line the fine sorry just a second ka si khanjala laiba ko screen je dun sing udaba ta so sir na iriba tension ki formula si khangbro ma'am
Không sir.
ꯑꯗꯨꯅ ꯁꯤꯒꯤ ꯀꯩꯗꯧꯕ ꯚꯦꯂꯣꯁꯤꯇꯤꯒꯤ ꯚꯦꯂ꯭ꯌꯨꯁꯤꯁꯨ ꯌꯥꯝꯅ ꯃꯔꯨ ꯑꯣꯏꯌꯦꯕꯀꯣ ꯍꯥꯏꯕꯗꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯅꯪꯅ ꯍꯥꯏꯗꯤ ꯚꯔꯇꯤꯀꯦꯜ ꯁꯔꯀꯨꯂꯔ ꯃꯣꯁꯟꯅꯤꯀꯣ ꯁꯤꯁꯦ ꯒ꯭ꯔꯦꯚꯤꯇꯤ ꯂꯩꯗꯣꯏꯅꯤꯀꯣ ꯍꯥꯏꯗꯤ ꯍꯣꯔꯥꯏꯖꯟꯇꯦꯜ ꯄ꯭ꯂꯦꯟ ꯑꯃꯗ ꯆꯠꯄ ꯅꯠꯇꯦꯕ ꯚꯔꯇꯤꯀꯦꯜ ꯍꯥꯏꯗꯤ ꯃꯦꯔꯤꯒꯣ ꯔꯥꯎꯟꯒꯨꯝꯕꯅꯤꯀꯣ ꯚꯔꯇꯤꯀꯦꯜ ꯁꯔꯀꯨꯂꯔ ꯃꯣꯁꯟꯅꯦꯕ ꯑꯗꯨꯅ ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕꯗꯤ ꯅꯪꯅ ꯀꯩꯒꯨꯝꯕ ꯍꯧꯖꯤꯛꯀꯤ ꯃꯥꯁꯁꯤꯗ ꯏꯅꯤꯁꯤꯌꯦꯜ ꯚꯦꯂꯣꯁꯤꯇꯤ u ꯑꯃ ꯏꯝꯄꯥꯔꯠ ꯇꯧꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ ꯊꯤꯇꯥꯁꯤꯅ ꯑꯁꯨꯛ ꯑꯣꯏꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ v ꯒꯤ ꯚꯦꯂꯣꯁꯤꯇꯤꯗꯨ ꯀꯩ ꯑꯣꯏꯅꯤ ꯍꯥꯏꯕꯗ u ꯗꯁꯨ ꯗꯤꯄꯦꯟ ꯇꯧꯏ and ꯊꯤꯇꯥꯗꯁꯨ ꯗꯤꯄꯦꯟ ꯇꯧꯋꯦꯕ ꯑꯗꯨꯅ ꯅꯪꯒꯤ u ꯒ ꯊꯤꯇꯥꯒ ꯈꯪꯉꯗꯤ ꯑꯗꯨꯒꯤ ꯖꯒꯥꯗꯨ ꯂꯩꯒꯗꯕ ꯚꯦꯂꯣꯁꯤꯇꯤꯗꯨ ꯁꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯦ ꯁꯤꯖꯤꯟꯅꯔꯒ ꯑꯗꯨꯝ ꯌꯥꯝ ꯂꯥꯏꯅ ꯄꯨꯊꯣꯛꯄ ꯉꯝꯃꯦꯕꯀꯣ and then ꯀꯩꯗꯧꯕ ꯃꯥꯒꯤ ꯇꯦꯟꯁꯟꯗꯨꯁꯨ at every point ꯇꯦꯟꯁꯟ ꯑꯝꯇ ꯃꯥꯟꯅꯔꯣꯏ ꯀꯣ ꯁꯤꯗ ꯂꯩꯕ ꯇꯦꯟꯁꯟ ꯍꯥꯏꯗꯤ ꯊꯤꯇꯥꯗ ꯂꯩꯕ ꯇꯦꯟꯁꯟꯗꯨ ꯄꯨꯊꯣꯛꯀꯦ ꯍꯥꯏꯔꯒꯗꯤ m/ru square ꯃꯥꯒꯤ ꯀꯩꯗꯧꯕ ꯊꯤꯇꯥꯁꯤꯁꯨ ꯏꯅꯤꯁꯤꯌꯦꯜ ꯚꯦꯂꯣꯁꯤꯇꯤꯒ sorry ꯇꯦꯟꯁꯟꯁꯤꯁꯨ ꯏꯅꯤꯁꯤꯌꯦꯜ ꯚꯦꯂꯣꯁꯤꯇꯤꯒ ꯊꯤꯇꯥꯒꯗ ꯗꯤꯄꯦꯟ ꯇꯧꯋꯦꯕꯀꯣ and the remaining all these are numbers ꯍꯥꯏꯇꯥꯔꯦ so ꯁꯤꯁꯤ ꯒ꯭ꯌꯥꯟ ꯇꯥꯕ ꯉꯝꯕ꯭ꯔꯥ ꯉꯝꯗꯕ꯭ꯔꯥ ꯃꯌꯥꯝ ꯇꯥꯕ꯭ꯔꯥ
ꯇꯥꯏ ꯁꯥꯔ
ꯇꯥꯏꯀꯣ so ꯁꯤꯒꯤ ꯐꯣꯔꯃꯨꯂꯥ
ꯇꯥꯏ
ꯑꯅꯤꯁꯤ ꯑꯃ
ꯁꯥꯔ
ꯈꯪꯖꯜꯂꯣ ꯁꯤꯒꯤ ꯁ꯭ꯄꯦꯁꯁꯤꯗ ꯑꯗꯨꯝ ꯇꯧꯕꯕꯨꯗꯤ ꯌꯥꯏꯑꯕ ꯍꯣꯏ ꯑꯇꯣꯞꯄ ꯄꯦꯖ ꯑꯃ ꯑꯣꯏꯅ ꯇꯧꯔꯒꯦꯀꯣ ꯑꯗꯨꯅ ꯍꯦꯟꯃꯟꯈ꯭ꯔ ꯃꯥꯜꯂꯦ ꯄꯦꯖ ꯑꯃ ꯍꯦꯟꯖꯟꯈ꯭ꯔꯦ ꯀꯩ ꯆꯠꯈ꯭ꯔꯦ ꯗꯁꯕꯤꯟꯗꯨ ꯑꯣꯀꯦ alright makha tawsiko sigisi inazik sinamzi kakradamne ko manungise ihe circle du ju yaugre ba ko aduna kai ma circle si tang puthoga sinamai ka thatpa ko alright fine hazik amuka kai dawsige ha matamda magi kai dawa final velocity si kaino tawjeba ko final velocity puthokre tension puthokre aduga masi kaidoba kai bu chatkani habado adu puthokseba ko andak mukna angles yengsi ko let's say masi asengdi sida leijaramane ko initial position sisini aduda sipo chatle ang khalajeba ko ana magi free body diagram tang yek thokke so smile ni and then CCR or any sorry kaidoba CR or any CCR or any and this is kaino have the CGC MZ ni ko and then C angle dina let's say hazik theta sinagre ko ana some angle atopam sinaji phi gumam sinarse ko so adidi sida laigada magi tension Tm le ani tension ko du le ko so hazik akoina okay fine si lere ko audai magi kedoba sida laigada velocity putok seba ko duga si kaino si bob se ko sida option ge na nasai nga ko aina pami positive height h is equal to just complete a particular circle of diameter d the height h so height h ko okay fine kai hoba chatkani have adu puthokse ko angle phi se ko kai bu chakani na anyway fine si lere ko aduna okay fine si lere som lere yare adu regadi ke doba koina ngasai to budu torji ko koina ngasai to isi kaina the application of conservation of mechanical energy neba auna potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final never ko so potential energy initial is 0 ni kem kaide but kinetic energy initial di half mu square lopsalage initial velocity is maji u da never u da never ko sakise square nate yare is equal to potential energy final potential energy to the mz harga r plus harga sigi pochidi kaino habda phi harga di r cos phi le ni ko r cos phi then magi kinetic energy dong hapsi ko just a second magi kinetic energy dana kai werni habda half m harga magi sida leiba velocity do ai tare ka sida leiba velocity do v ni lor si ka so that will be equal to half m b square ka c phi sida c sumai le en khalas now akoina kaigumba mana sigi pot si kai bu sakani na khali si bo chat laga lep kani na khalaga de akoina velocity ji amuka zero lor ka duine ba ko aduna we'll come to that now kaidoba magi free body diagram ji dagi magi kaidoba velocity gi equation ang putoksi ko c gi diagram ji da kai la kings so aduna kai la kani habda centripetal force mb square by r yare ko then c kai ga manani this should be equal to haraga t t lere ko tension lere t plus haraga mz cos phi ga manani mz cos phi ga manani c gi si kyan tabra ma'am
Tayo, sir.
tai ka okay fine c gi si kano to ba gyan ta da ba yaubra thongon ba gyan tabra si se thongon ba je yaudra ba
Sir, tayo.
tai ba ko asterisk tabra Lakshmi tabra
Tayo, sir.
sisi tai ko okay fine yare kai you have the c zina mg or the some side zina mg cos phi and some side mg sin phi ko anyway fine now akoina kai khang have the tension have is always greater than or equal to 0 line tension cannot be negative and tension cannot be negative hai ji kai na matam da rope si the tension lai bai ji kai na Haziki bob si chap ting na farthest possible distance I my centripetal force chinga chat le haine again it doesn't have to be horizontal motion ko is vertical or si but tension do lai gadam ne tension lai ta ta ga di ke dong ne matam da tension lai ta ta ga di kai dong ni ha ba da rope to phadrak ta ni or string do phadrak ta ni aduna adududi akoina kedo circular motion oira my path to circular oira oiba path to circular oigi hagadi tension is zero oidaba zero oibia de negative oibia de it has to be positive at every position except one position and masigi one position ji kaino have the at the particular id is keep at top se topmost position the for example sumaile rank kala je ko adu ergadi magi kedo ba sigi sida si sumaile na ko aduna my sigi top mose sigi top position jidadi tension 0 or siya ko sigi top position ji tension 0 oira suma ji still circular motion chakane ba kai gino hai matam da sigi top position jidadi ne kai dawni hai matam da mana tension 0 oira ga su maji kai dawba maji already motion da lai bani na momentum duna guide tawraga the my velocity of the move to the next instant maji lanthok rane ba sigi jaga ji lanthok raga kaidoro kani amuk chingba horane ba gyan tai ko aisa auna adum tension je sida di compulsory masam tan lak ba horne on si point sida katang tension 0 be ai so si point sida katang tension 0 be ai ba ko kari gino have the kaina ne haiba jikido inertia na guide to or momentum or inertia duna sida tension 0 erga su ma next instant ai di kedo ba adum chingchal laga maji circular path am dum salakani bu ko and at any other place tension 0 be ade sida tension 0 be ade sida 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 yade but only sida katang yae and they go asi sida katang t is 0 be ai yadra ma'am yai ko auna tension ja 0 be ya position amalay topmost adu atay at all other positions the tension should be greater than 0 and it will still be circular motion ko ado top the 0 oini have the like oidrasu yai but oiragasu yai have ko auna akoina kedo we have the sig equation just seasonarga so let's say this is equation 1 let's say this is equation 2 and let's say this is equation 3 so equation kitang kanang to malawa is 2 and 3 ko 2 and 3 seasonarga ina if t is greater than 0 then kai have I mb square by r minus mg cos phi should be greater than or equal to 0. Gyan taita de taiko. Aduna m kakre ko. Aduna v square should be greater than or equal to zr cos phi. Sumay libra. Gyan ta bro, tada bro. Taiko. Ma'am, sige se. T should be greater than or equal to 0 openina sige po siya from the la amazi asom chakre ko ona v should be greater than or kedoba gr cos phi na ko si sumain lei ona aina ngasai gi sidagi sigi velocity gi equation ama thamobana phawjani ko ai ama thamoge ko haidi kana plan thodre kamaina tawjige na ko so amtang thamoge tung the problem laktana vai tai ko si dum ya lesson it implies sarga v square c kai tani yeng siko sidai sida neo v square c len ka kre m ka kre m ka kre m ka kre auna u square minus zr minus z minus 2zr minus 2zr cos phi yare ko si lei so let's say this is equation 1 2 3 ko auna aduga let's say this is equation 4 harse ko auna equation 1 and 4 amu sizinarong tawgadoni ko so yengasi auna equation 1 and 4 implies v square gi mota kai lere the u square minus 2zr minus 2zr cos phi should be greater than or equal to zr cos phi adu oiba taragadi aina u square is equal to asom pugragadi 2zr plus arga minus kidoba 3zr cos phi yarba yai ko si sumain lei so aduna si sina haining is kaino ay matamda nangi phi duna let's say aina kaigumba ko phi is 90 degree oren khalase ko id phi 90 degree is karam kanu ini ay matamda ko si formula sem p gi aduga munne ngo ko if let's say kamay hai sige sila ni phi de ko ana if kaidoba let's say aina sidai sida ko position nama loge ba sida p1 an loge ba sida na p2 an loge ba ko habidi if kaidoba phi is equal to 90 degree that is kaidoba at kaidoba p1 adur gadi magi initial velocity use kaitani have the root over 2zr ko root over 2zr dang tai ganta rise kai no di cos 90 degree 0 ni na ganta ko if phi is equal to let's say 0 degree that is at p2 adu di use kai tani root over cos 0 degree di 1 ni na root over 5zr tai ko so si ganta bang ambra ma'am tai ko auna si sina position ji kai de leine ab si de p1 auna magi kai do ni have da magi phi do si da phi do 90 tai de na ko adu maina adagi si sina my position ji kai le ba top te le ba ko auna si da na kai do wi ha matam da si ta na yo laga lepan ge or si tan le adi kai ne pot se ngasai gi si da ina u velocity the cap khre ko adu sida exactly c yon ga ga ina root over 2zr root over 2zr higher initial velocity sida ina posi kaidoba if I impart a velocity equal to root over 2gr then it will reach exactly at p1 haidi magi radius ki mapa do mai horizontal level da yora tarakane ba ada ina kayumba root 5gr exactly yorba adu di ma complete circle set krani kai ginodi si maton jibu yorba adu di next instant dai ma si yoraga magi momentum duna magi kaidoba inertia duna guide toraga si gi position p2 jibu yordem lantho gadam circular motion complete oine ba auna vertical circular motion ji complete ohen gyar gadi minimum velocity is root over 5gr ne ko and exactly my horizontal level do ngasai gi my center gi do adum pa pu yon ga na root over 2gr with ne ko pau phona bra ma'am loina mak si is everyone clear with this
Yes, sir.
Hoy, sir.
okay
sir.
Lakshmi gyan ta bra
Tayo, sir.
tai ko okay fine so ado sir na si am wana adi kain si ma explain to kai na some important oina khan bai ne ko si ji adu ini. So let's proceed that long to solaji ka. And a mass M is attached to a thin wire and whirl in a vertical circle. The wire is most likely to break when inclined at an angle of 60 degrees from vertical. Mass is at the highest point. The wire is horizontal. The mass is at the lowest point. So tension ji kai dena maximum oini hai matam da tension gi formula yengo. Tension gi formula ji noina kai do wasi da yenga su yai tension aini si da tension putokra. Si da putok na mama gi dio. Tension की formula का चक्कर yes tension की formula जी काई देना कोई दे चावनी सी की term जी zero चक्र कांदे चावरोइद्रा चावनी को अरे हैबिटी कहीं ना m by r u square जी दी दम याव दोले रे 2m जी याव दोले but 3m जी को सिता जी ना कहीं गुम्बा 0 degree थीटा जी ना 90 और गदी कहीं हुई नहीं cos 90 degree दी 0 ना ट्रा यान ताब्रो ताब्रो ताइको zero set penalty sorry सी term जी ना कम कांदे कोई चाव करनी है बदा theta is 1 cos theta na 1 or kanda ko aduna kaido we have the it implies kaido what t is maximum when theta is equal to 90 degree kai no di cos have the cos theta is in a chawen chaw the 1 never sin theta cos theta ki value na chawen chaw the 1 never adu no 1 we ga di 3 mg is direct plus to ka do never 1 with the half or root 3 by 2 or 1 by root 2 or any other value at minus 1 then 1 any value of the tension to picture a and tension in a quite chow where the 3 mg direct plus to over pangadam never. So 3 mg direct plus to where the cositado 1 tagadaba. Have the titado? Titado 0 degree have sorry.
0.
Yes, yes.
Sir, the question sir. See, do sir, the
okay, fine. Yengiko. Question number kya no?
Sir, question number 39 though.
Okay. Question number 39 is 2021 is a car. All right. Okay, fine. You see. So just a second. Kingston, sila ko. Sibla question thara ijo. Question ji. Then noise question khang dab tha chalo sir da. Sir nam solve toge. Okay, fine. Yare ka. Sima mang the printer message. De magi sida. Question number 2019 is ima moin skip tawgraba jikitu de yawdo malida. Anyway, fine yare. Moi going to 2009. Oh yeah. Okay. 2021 the question am hange ko. Anyway, fine. So ngai ko ajik akoi na trom ji jikitu tawsi and she ju tawsi ko. She han discuss trom na she han adam loi thosi. So noi hero kayo ini si jikidi. Sir, now how's it discussed on the night? Tension ji kai the maximum wave theta 0 or kan bottom da ana bottom da na kwai de hen maximum moi ni ko ten aduga theta ji kai de na minimum moi ni this is na minus 3 mg cos theta ji na minus 1 or kan da sigi tension gi value ji kwai de 100 to na tro so cos theta na minus 1 kam kan moi ni 180 degree exactly top the but pura the highest position the tension ji minimum lowest position na tension ji maximum moi to gyan tai ta de tai ko aduna di kai or ni sigi sa option number kai or ni abcd
D.
D or ni the mass is at the lowest point see the tension ji maximum the wire is most likely to break as tension the maximum or can in a tatu one. So yare matang the ziki question no see. A particle is released from height s from the surface of the earth. Okay, at a certain height, its kinetic energy is 3 times its potential energy. The height from the surface of earth and the speed of the particle at that instant r. So it has nothing to do with vertical circular motion. Shidi cham chamba conservation of mechanical energy pan gadabani ko. So yam live question ni height s tagi kedoba particle is released from height s from the surface of the earth yare. So at a certain height, its kinetic energy is 3 times its potential energy. So let's say height s ni, this is height s. Shidagi pochi kedoba sum tarak pazina kai dinoma yo matamda at a certain height h. Sigi shida magi kai lay matamda. Its kinetic energy half mv square is equal to 3 times of mgh. The height from the surface of earth and speed of the particle at that instant r respectively. So sigi height sigi sina magi h to sigi h putho haiba and then the speed of the particle magi speed v is equal to what and sigi hang maneba ko s tagi thadarakpa matamda s from the surface at a certain height its kinetic energy is 3 times its potential energy. Okay, fine. So the height from the surface of earth and the speed of the particle at that instant are okay, fine yare. Okay, so akwina kai khangi hamatamda moina pyramid se dum tawsalaji ko m half mv square, sorry, half mv square is equal to 3 times of mgh never gyantai tate tai. So there get the half m arga v square di kaino have the root over 2zx is equal to 3m z arga my distance na kaino have the h di kaino s minus x. Ngaura basi sa ngaura
Yes, sir.
ngaude ko sisi kaino have matam na mana taraiba distance, let's say this is x distance taraiba ko my total height to na this is total height ko total height s ne khala jeba ko aduna adwain legeduni. So adu ergadi noi gyanta de haro ko ana sisida noina m ka kre 2 ga zu ka kre aduna g square x nate z 2 ga nate z ga x ka lere ko adu di x puthoge ko la the let's say zx is equal to 3 zs minus 3 zx never ko auna x si pungragadi z juloin kakre z ga kakre auna minus 3x is puro the 4x of the 3 by 4 s tare x ka 3 by 4 s yaubri angu s by 4 s by 2 s by 2 s by 2. Now x second will have a neighbor 3 by 4 s have a neighbor ko height to put okay argadi h to put okay argadi kaino have the s minus x neighbor auna s minus 3 by 4 s which is equal to 1 by 4 s tare auna s by 4 s by 4 s by 4 option a ga b ga c ga si chumba yai karamba chumduino have the koi khangdri aduna will proceed with the velocity. So magi velocity square ka so magi velocity di kaino have the at that instant have not speed have not yes adu the root over kaino 2zx. So 2 le z le isi line me yausala position in practice. So root over 2z le and what is my x di kaino 1 by 4s adu ergadi kaino have the 1 by 4s have yabra moise kaino my okay my velocity so my leave ko so sorry 1 by 4s natine 2zx hagadam 2zx so 3 by 4s la ni buko aduna kay tarni 2 zina sida ka gadi root over hairaga root over si punam thammasya punam thammage ko aduna farni aduna kai leni have the root over hairaga 3zs by 2 tare so aduna option A is the right one mayam si gyan tahudabra ngaubra khara
Ngaude da sir.
Ngaude ba ko thangamba
Hoi sir.
okay atai di Lakshmi Sunanda asterisk Kingston
Sir.
Tan.
Lakshmi di tarba Lakshmi kumta di Sunanda bu tare seng na kum ko ta dai ta de ha ba noi sir na sum khan ba noi ne struggle to ba si gumba se 2gx kai di line o kana ko si dum khangjalo si je have the height x pu tara ga di root over 2g have the isam jam na v square minus u square is equal to 2gx hajalo ne ha distance to id simply take it as x oina ko x oina lo salo adi di ma di free fall in initial velocity 0 ni na v is equal to root over 2gx adum tare na ko otherwise line m6 gantai ko isa so it's a very simple question. Let's proceed. Matangda C question ji leire C question ji sir tawge ko question adum phajaba question oibani sis so C question ji noi adum ngamgadam mi yaubra sir adum tawrora sir na budi tawge du su ngamgadam mi yaubra sis noi ma kun ji khang tap san gre ngo kai no de tabra
Chatai.
oh
Chatai.
Aziyam hore so okay fine sir adum solve tawro haira
Hoi sir to biro.
okay a body ko initially at rest and sliding along a frictionless track from a height h as shown in figure just completes a vertical circle of diameter AB equal to D. Okay, fine. So the height h is equal to have a C height h put away. It's a very simple question. Yam live question ni ka. Now, magi kuina kinematic question put hoga magi sigi velocity ji put hone bu ko mana. Yan dai ko so aduna mazi si the rest ni u dagi v da la ka ni ka. So akoina kai khang ya matam da v is equal to root over 5zr 5zr do di kai not d by 2 velocity da si lere ko okay fine so si na kai kanai ba khang de koi sigi velocity khang but again sigi height h cd akoina kamai pu to kan ya matam da magi initial velocity is kai no u is equal to 0 v is equal to root over 5z d 5 by 2 zd lere ko root over ji pull up ni ko and then yes manika then kai a zina kai no a zina pot si som da ching daram ni na fdc pot si sumai lere so si lere ni som da lere ni na magi ji kai no da mz mz sin theta har ji abra acceleration je ko sin theta gi muhutta mz mz sin theta budi labor ko which is equal to mz sin theta di kai no opposite h by s ka hejala jira h by s na ka so mana putho ic h to putho m ne ka auna v square minus u square is equal to twice as ka natraga v square is equal to u square plus twice as ni so sigi pot si yang kalai ni ka and everything is positive so everything fine so v square di kai tarni 5 by 2 zd tarni u square is 0 tare 2 le acceleration di kaino habda acceleration di dai mass apa ji kaino ai kaino ne mass yauroi ko so aduna kaido we have the answer is talasi so magi si kaino have the z into h by s lere into my distance to s and lore on ss ka kre ko audai kido ba ss ka kram z ga sum ka kraba ka kre then aduragadi h is equal to 5 by 4 times d so option number d is the right answer ngaur ba gyan taudra ba
Tai, sir.
gyan tai bu ko
Done,
gyan
sir.
okay
Sir, tie.
Tai, sir.
tai bu ko adum live ni de ko simu questions live live ne as in na vertical circle motion ni kaino kham jaga di yaro de ne du de ne bu ko then sorry so anyway so sumailai let's proceed si doing tausan graba all right kona sem dole so question number 41 42 43 no pa mong khala 41 42 43 question number 41 ji kai weni haro ma'am
B.
very good option number b weni ko root over 5 zr show it all right question number 42 43 44 yeah question number 42 is a particle with total energy E is moving in a potential energy region U of X. Okay, motion of the particle is restricted to the region. Okay, fine. So, now potential energy C kaidoni hamatamda magi kaidoba a particle with total energy is moving in a potential energy region. For example, mazi let's say akoigi potential energy labor region agadi ground earth gi pot ama swain chum geno to le matam my potential energy is E dagi thai total energy E dagi kaidoba PSI or sawa energy but E dagi hen mati sunya yaroi ba gyan dai ga ja aduna potential energy zero da kaino to le have CDM ko my stable equilibrium da hen leng dre it is not moving at all aduna sisima yaroi potential energy can never be equal to can never be greater than total energy potential energy can be less than E yes option A is chumbadi yai but option C is in a hen chumme kaigino di kinetic energy to zero or potential energy to total energy ka manar option C is the right answer gyan tai ta de ma'am tabro ta de bro
Tarni, sir.
tai ko option C is in a quite hen chumme option A is oibadi yai but case amaneba the kinetic energy lay case never option A is na kinetic energy so later di potential energy duga total energy ga manar ka doineba aduna option C nen chummeba option B is na my stable equilibrium de length de the lay the rest lay the adu neba option D is not possible now question number 43 44 yang 45 si yang biar 43 dies again. A stone is tied to a string of length L and is whirled in a vertical circle with the other end of the string as the center. As the center. Okay, yeah. With the other end of the string as the center. At a certain instant of time, the stone is at its lowest position and has a speed u. The magnitude of the change in velocity as it reaches a position where the string is horizontal is very nice question. Horizontal position, my velocity do. Okay, fine. Kaya ada kino tau ni. Kang bra kau ba. Okay, I see your question. Share tau ko. This is a very nice question. Kai de tau si de jing question fazai aina ngasai takibda adu exactly panba yabra habdo adu maksung oide habdi kaina CCD application ne ba ko now and is whirling with the other end at a certain instant of time. The stone is at its lowest position and has a speed u. The magnitude of the change in velocity as it reaches a position where the string is horizontal. So, sumai lere aduga c da lere. So c ki position ji yo matam da my velocity is let's say v ne khala je ko. Adu ergadi where the string is so g being so adu ergadi magi kedoba magnitude of the change in velocity ki magnitude putwa b minus u ki magnitude putwa yare ko okay fine so adu betaragadi zigeng asiko kai ta gena now akoina u di am kamoi dum u dum pirame ko atopa kaimta keno toramdre duga v is in terms of u da putoke haragadi kai tani habdune ko so let's use the mechanical conservation of mechanical energy on a 0 plus half mu square is equal to mzr plus or mzl harage my length l oibani ko string gi length na radius oiduni so mzl lereko plus half mv square adu oibataragadi m loin kakre aduna v square is equal to u square minus gl u square minus gl tare sorry minus 2gl tare ko aduragadi na v is equal to it implies v is equal to root over u square minus 2gl lere ko auna kaise kare yare so c na v ne the magnitude of change in velocity putwa ibne ko auna delta v is equal to v vector minus u vector ne ko so moina vector piram dabjidani factorize ko all right so no worries moina change in magnitude ki wari magnitude to the magnitude of the change to gi kana to ko amazina z capital any direction zemana capital any ko as the magnitude of change in velocity have never got. So a minus b is again. Alright, so towards the car, do a good kay tai hamatum da queen a kay kangi a sigas I don't talk sure again. Kay tor again have that. Sizikai have that we know it is sorry. Edowa v vector minus u vector never car do put one do the kay gamane. V square plus u square minus 2 ub cosita natra to vu cos theta gi but again when is perpendicular in a 90 degree in the yaro only k do v square di k u square minus 2gl minus araga u ko lere sorry minus u square haidam natra kaidanom square ba yes this is a plus araga u square hagadaba yai ko auna root over kay tare 2 araga u square minus gl. So option number A is the right answer. Gyan tao bra si se, ma'am. Ngao bra. Gyan tai ko. Sigi se. Si yung v square d u square minus 2gl na. Aduga ka u square do di u square le na. Sigi cos theta di it is 0. Theta is equal to 90 degree. Adana si term se this is equal to 0 eta. Gyan tai ta de.
Tai sir.
Tai ka Lakshmi tai hare. Atai di Sunanda.
Tai sir.
Sir, tie.
Matai hare. Adagi kenodi Asterisk, Kingston.
Yes, sir.
Okay, fine. So let's proceed. Question number 44 to 45 is the hero. So that's long hero. Question number 44, 45. A child is sitting on a swing. Its minimum and maximum heights from the ground are these and these respectively. Its maximum speed will be okay. Yeah. No. Kaino have the conservation of mechanical energy pandeni. Ngamgadra ngamoidra. Magi yumne. Magi its minimum and maximum heights from the ground are so duna magi half m v square is equal to mz harga h to 2 minus 0.75 t 1.25 tabra. Ngawra jigida. Kanam ko magtre. Question number 44 is sir holora nui ngamgadra. Saja hainaro. Hot seba. Okay. Asidi am live question never ko. Again, sir na ne. Nui hot po matamda. Kitanga matam changba mali nui explain to way ni ko. Kayuma sir na sir ji test haring khala jeba nui sigi same question jida dur day direct answer yarige answer tu na yawno hona ni ko. For example, I see the tauge ba aina kayuma exam jida thaba or gadi kamay hot kani hai bata. Ana magi initial velocity to half mv square is equal to harga mz kay do ba h to again I did direct iningi ba ko. Anyway, I sumaina dum CM di half ki ke ko 2.75 na. So m ka kre aduna v is equal to harga root over harga 2 into 10 into 1.25 le. So 1.253 ni on the root over kay do ba yes 1.25 into 2 di kino 5 la manika. So 212 okay 5 to 10 2 2 4 5 5 kay do ba dura ka de 25 tare ko root over 25
5 tadu.
5 tar ya rasi se ya ko
Oh, sir.
so now si se ngau bra ba noi da si gyan ta da bra ba
Tayo, sir.
dai sunanda tare atai di ta bra ba Lakshmi asterisk thongamba
Why, sir? Yes, sir.
haro Lakshmi haro
Sir, half mb square equals to mg haraga 2 minus 0.75 ite. Karaitegi lakhi khangdoin sir.
Okay, no worries sir haige ko so sigi angang jigi suppose let's say swing ji sumaina angang sidai jida phamme ma ji ko makong yan thar sidai phamme ma si sigi da tong ai sidai pai ra ga ta ko now kai do we have matam the sigi swing ji ngatang le ga swai da leigre ko aduna swing sigi magi kai do wa sidai yore so magi kai do we have the ground dagi sigi height si kai oi have da sigi height si 0.75 meter neba aduga amazigi height sina ground dagi h dia sina kai oi habida h2 sina kai oi habida 2 meter neba ko sina h1 harage ko aduna kaidawi habida magi di sida di kaino habida magi sida u velocity ama laini sida di magi v to 0 neba ko final velocity do auna akoina conservation of mechanical energy palaga magi potential energy to the kind of the mz h1 plus half m v half m v1 square or half m u square half m adum okay v1 square is equal to harga mz h2 plus again my velocity is 0 never half m harga v2 square never so v2 square is 0 yarba Aduragadi is the kaitane of the half mb1 square is equal to mg h2 minus h1. She's in a tro. So she told you, Munio. Someone address it. Yo. Lakshmi gyan taba ngambra tadabra hero.
Tarani sir.
Senge ko, yare ko.
Oh sir.
So adumaina ko, sumain to budini. Now let's proceed. Ihe ay kainam sengre. Okay, fine. So question number 45 Sidino hero. As shown in the figure, a mass is performing vertical circular motion. The average velocity of the particle is increased. Then, at which point will the string break? String je kaida na kwaide na tatkani. Kaida na kwaide taningani. Tension kwaide hen. Yes. So kaida hoite na do A, B, C, D.
B the order.
B. Very good. So option number B ka. Sometimes noigi kainojina noigi the A dana C o henba or the second option sidana the D o henba third dana kaidoba A o henba fourth dana B o henba kaidanga twist of yakune na mithakanu ko adumba sibudi A B B C C D D or amena nungaiba ado anga twist of the bab to amma khalling the kanoma option no yeng of the magi option no piriba kaino do the yeng da bida ko. Okay, fine. So now potential energy of a spring. Two similar springs P and Q have spring constant this and this. They are stretched first by the same amount of work. Blah 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 blah. Okay, fine. So spring any series ka parallel gada sambagi gumba question mali sigisi ka. So yam live any ka. Then various form of conservation. Okay, fine. So I do dumtang tak ke question budi hot panang da bay I pungze asalak tre. But I'll just try to cover as soon as possible. Okay, fine. So spring se kedoba spring ki ka combination of springs hai ka series ka parallel ka torse. Noi khang di khang bra combination of spring the series na kai formula le parallel na kai formula le have to khang di khang bra.
Oh sir khang.
Khang hai ka. Okay, fine. So my spring constancy let's say K1 K2 beta aga di series sa samadi kai weni Kx to kai weni
K equivalent to K1 K2 by K1 plus K2.
K2 very good kai ma parallel orga di
the direct sum dorani K1 plus
K2. Okay, fine. Very good. Jume. So quite first the series and some site and parallel doors. Now, sir, assume my di chora ko makai di line have ma high ge ko yam tu na high ge kem ta ID matam changa loi se di kenoni na ko. Yeah. So let's say this is K1 and let's say this is K2. Assume the na parallel sum the ni ko. And the more is easy common no forum da ita ko mass. Smart to sum me. Na na pull up mass so the sum is yai ko. Kaim kai de. So direct as K1 and let's say K2. Yare ko. Now, how is it Quina Kaidoni Hamatam the Magi Yengasiko Kaido the series Tana Kamain Toraga KS to Kamain Putoxige Sidana Kano the Sidana Kamain Putoxige. So Magi restoring force F1 Zikaino have the K1 X Lernica Aduga F2 zina kay lerni K2 X lerni. Som site na kay lerni F1 is equal to kay lerni have the again chamanay K1X and F2 is equal to K2X. Chapti manay. Okay, fine. So parallel ko. Okay, fine. Now when these two springs are stretched by the same amount adu betar gadi kaidi parallel or mean same amount stretched or neighbor ka auna let's say this is x1 and let's say this is x2 neighbor ka auna sida di kayo ni sida xx o neighbor have the parallel in the same amount stretched or neighbor ka aduga series tana kayo ni have the same kaidoba force na stretch tawgadineba yan tai ko sidana same amount na stretch tawgadeba auna koina kai khangi ha matam da sigi sida koina adu ebe taragadi ko common ko f1 plus f2 is equal to harga k1 plus k2 times f. So f1 plus f2 is equal to k1 plus k2 times x. f1 plus f2 z kaino ni ko ngasagi f2 ko manarani aduga sigisina kp x and targa koina kaiga mane ha matamda kp is equal to k1 plus k2 na smile chat ka doine ba aduga som side na kaim ga mane ha matamda f is equal to c le ka duna f to manarani we have k1 x1 is equal to k2 x2 le ka. Okay, fine. So adu oiba targadi aina kai loba yai ha matamda moini combination c kaidawa parallel dadi kai maneba force cha mane same force na chingdoineba same force na ching matamda ahamba sidana k1 x1 lakpa akon bai sidana k2 x2 lakpa ko now see the sir minus kai chat kai khallagadi it is not vector here I'm considering only the magnitude ko ana kemta kai belaite. Okay, fine. So si lere aduna sidagidi aina pam si kaino have the fs pam ka total force to aduna total force fs will be equal to f ka adu into ge adu into no fado mali. So aduna here I'll get fs is equal to let's say kayo ini have the ks into x ne lower zibuka ks into xs kai lorja. Okay. So kp has x logo ko same way kita ba x ka and f1 plus f2 dana si sida parallel gi oina f oy ba ka ada sida na f1 f2 do manare ka dana fs2 so chapu di manare ne ba ka but magi sidi xs and la ne ba ka. Okay, fine. Si lere adu oy ba targa di aina kai do we have the I can write fs as k1 x1 ka force common oibane ka force common oibani na force common oiba amma sidana kai common oiba amma sidana magi kaidoba stretched away amount to common oiba ka auna force ani sam taw sidana x1 plus x2 oiba I'm sorry yare si yare ka aduna kai oinya matamda this will be x. Now we know x1 plus x2 is the total x to tani buka. So I'll just write it like this. X is equal to x1 plus x2 na irage ka. Answer tare. Si sim talung si log to kito. Okay, fine. So do we bitar di ko na kay tayo ha matamda x di kay no xt fs by ks x1 di kay no f by k1 x2 di kay no f by k2 adu di f s to f lon chap mana baina 1 by ks is equal to 1 by k1 plus 1 by k2 na sumain to orga koina we get the formula for series ki oina pange and this is also very important ma'am sigi gyan tahubra hero
Sorry, sir.
tai ka
Taoism.
tawi ka aduna sisina kaino gi formula ne sisina kai gi formula series ki formula hai tare ka this is ks. So habidi kaino hai matam the same restoring force this is the common restoring force there any same line ina sina kaidoba sidana same displacement to x to chap mana ne ba yan dai ka habidi na series study kaino habda f1 is equal to f2 is equal to fs neba, and magi counterpart parallel dana kaino habda x1 is equal to x2 is equal to x neba ko. So this is the xp ha parallel gi oina ko. So gyan loin tahu ena obi are ko yai ko yai. Okay, fine. So sile, all right. So aduna masi formula si ina makado ina thambana di pabra. Hey, yare. System khangam ni na ji koi, let's proceed. See mo LM equal to torge ka. Question number 46 sima try to si 46 47 na dang try to ga masi class lo shudla si. Two similar springs, P and Q, have spring constants Kp and Kq such that Kp is greater than Kq. Okay, they are stretched first by the same amount, then by the same force. The work done by the spring, blah blah blah. Noi khangbra khangbami haro khangdami na khangde haro sir dum toroke kem kai de question jidi am lai. Sir ne lai hai na noi na hangakana ba nate ko hango dum. Khangbami yaubra.
Sir khangbude khangni answer da hakitan yengi sir.
Yengi ge yo yam kuina di yenganu ko pai kha da di yam kuina yengoi matam phangoi.
Sir, A oidora.
Hajikti haigiroi ge atai di
Sir, easy mo.
okay fine easy male ko all right atai kaino di Sunandaga Lakshmi ga di
Sir actually male is
Lakshmi di
Sir, B male.
okay kaiva Lakshmi is kai male ba B male ba B for ball. Okay fine now let's see ko obviously KP ni hele ko. Now if they are they're stretched by the same force and stretched over how many ko. So work done for spring P is equal to have the half KP XP square, and work done for Q is equal to have the half KQ XQ square ne ko. All right, fine. Now okay, we have the work done. Okay, fine. WP. So they are stretched by the same force. First by the same force. Same force haramnina aduragadi WP is equal to half haraga KP into XP kaino intorize. Or I'll just write like this. So I'm going to same force haramnina FP XP. Same force haramnina FP ga haroi. F haraga XP haraga. WQ sina kaino half haraga F haraga XQ haiba yabra. Sise ngaubra.
Wow, dear sir.
Ngaude ka. Okay, fine. Now hazik kaidu ya matamda aina KPM ga XPM ga KP XPD force ni KQ XQ zu force ni same force ni na si force ani di keno tawgre ko kam kenaro, but XP ga XQ ga do if they are stretched by the same force kana na hena less hoini habda KP na hena less hoini the XP na hena less hoini ba ko gyan tai ko isa this is in a kaidoni have the when they are stretched by the same force obviously sigi sida akoina compare to matamda kaidoni have matamda XP zina chawbanina KP na chawbanina XP will be less than XQ gyan tai ko isa auna WP therefore WP will be less than WQ. Option number B tare ko have the first ki part se then akoi zik amuka second ki part ong yeng si ko. Second ki part na kaino have the sorry second part ne sise same force second part ne ba
option number ado male sir
aduna sigi part chu me sigi asi part chu me ba ko id keno dan yeng re ba id sigi same force dan yeng tho re ba now same amount hai bani na xp ga xq ga chap mana ba tar ga d kp na hena chaw bani na obviously wp ne chaw ni ba ko ana si chu dum chu me aduna option number a or ni ba ko मैम लक्ष्मी की अंत होब्रो जी की तो लक्ष्मी बी हारम बता
ताहौदे सर
ताहौदी है ओके सर अमतंग हल्लके को केम कायदे तादे हाइगदम को वेरी गुड तादे आइदी सेंग हाइगदम alright so sir अमतंग हनगे उनको first part किसी के ना first they are stretched by the same amount ना wp की xp जी का xq के चप मना ने सी नि डिवाइड तौना सी सपोज सी डिवाइड तौना का सी नि कथक यारवा सेम way xp xq same amount हाइदो सिदा same amount हाइबदी xp दो xu चप मने सी कथक क्रेबा अदुदी but kp ga kq ga di kana hen chawge kp ni hen chawe ne piram dro mo sida kp na अदुदी wp na obviously chawroi dro half ju ka kre gyan ta dabra
ओ तारी सर
aduna si jimo a jimo chu me ko b jina uga kaina habda same force na ching hai ba and force ani du ka kre but xp ga xq ga di kana chawni habde kp ne chaw spring constant chaw ga di yam stretch to ngam moi ba same force na ching ba ko less ora ne ba xpp ani xq chaw ni ana cd constant ni si ke do si ni chap man re si jo half ma tani adu ba ta ga di work done du di xp da directly proportional ore on xp to pm ni na wp to p ani same force and stress to on wp na p ani wq na chaw ni so option a is the right answer यार बस इतनी लक्ष्मी की अंतर बा
ओ सर
आएगा okay fine so mine to udna कोई question number 46 lawyer question number 47 a block of mass m is attached to the lower end of a vertical spring the spring is hung from a ceiling and has a force constant value k the mass is released from within the maximum extent produced in the length of the spring will be have a cost system to orgalo shilazika so atai question ga sidin no okay no khallo 46 to gera sorry 47 48 49 blah 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 ma'am le no ina ngam bagai to ro so question number 47 you know ngam gadra haro sir na to usira ngam gadra
ngầm sir
ngam ni okay mi ama katang hack tangari
yado wo male
yadaw mal hai ka okay mi ni di sure mi ahum wali ka lakshmi asterisk kinction haro
sir khoba nin hai
okay
sir aini walije
oh thomambaro wali je okay fine haro lakshmi line ching chila male lakshmi line ching chila idu mutalo kem kai de ha yare okay soidena ching chila ko ni kem kai de so kenu haro thongamba lakshmi ga haro yadura try to bangam dura
sir try tawba ngamnida khangde
lakshmi di
ओ ngam sir
ngamani adudi question amtang di tawning mai na ko I think ngasi class se loisala je pung je arak 9:40 pm chatleba ko aduna noi dum try tawragera spring is stressed by each and the potential again sisima tawjira ten ma amtang di tawning ko ina ko okay fine so question number 48 tawjira a particle spring would a ball of compressed the network done in the process is have a question number 48 chiding gadra haro ngamni ha ga skip tawdini ngam wa ha disha tawdini haro ngam gadra
sang ngầm đâu mà ꯍꯣꯠꯇ꯭ꯔꯤꯕꯅꯤꯅ
ꯉꯝꯗꯧ ꯃꯥꯟꯗꯤꯌꯦ ꯉꯝꯗꯧ ꯃꯥꯟꯗꯦ ꯍꯣꯠꯇꯕꯅꯤꯅ ꯑꯗꯨꯗꯤ ꯍꯧꯖꯤꯛꯀꯤ ꯄꯥꯎꯈꯨꯝꯗꯨꯗꯤ ꯌꯥꯝ ꯂꯨꯏꯌꯦ ꯉꯝꯗꯧ ꯃꯥꯟꯗꯦ ꯍꯣꯠꯇꯕꯅꯤꯅ ꯍꯣꯠꯂꯒꯗꯤ ꯉꯝꯃꯝꯕꯁꯨ ꯌꯥꯏ ꯍꯥꯏꯕꯒ ꯆꯞ ꯃꯥꯟꯅꯗ꯭ꯔꯣ ꯑꯗꯨꯗꯤ ꯏꯟꯇꯔꯄ꯭ꯔꯦꯠ ꯇꯧꯕꯗ ꯂꯩꯔꯦ ꯁꯔꯅ ꯑꯣꯀꯦ ꯁꯣ ꯅꯪꯅ ꯉꯝꯗꯧ ꯃꯥꯟꯗꯦ ꯍꯥꯏꯕ ꯋꯥꯍꯩ ꯑꯃ ꯄꯜꯂꯝꯅꯤꯅ ꯁꯔ ꯍꯣꯠꯂꯒꯦ ꯑꯗꯨꯗꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕꯗ a vertical spring with force constant k is fixed on a table blah 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 okay fine so sumain tawraga spring am leme sida spring ji mathakta sumain sida ball am tak tare ball ji ma tak ta si yei the spring ji compress hoisalani ka adu regadi kedoba kayam compress hoige and then the net work done in the process adu process to the total work done kai ta ni have ka okay spring is compressed by distance d have ka adu regadi kaino hai matamda obviously this is so simple mg haraga magi potential energy change the ball sigi haitare ka sisi kai oine hai matamda magi si initial potential energy si mgh ne yare ka aduga magi si kaino hai bada sorry magi kaino hai bada mgh plus suppose magi compressed or matungda sawai de yore en khala jeba are si distance kaino si d ne gyan tai ko aduna total change di kaino mgh plus d minus mg mg adum mg h plus d tarni ko plus half k d square tarn so mgh plus d plus half k d square si tare option number d tare kena loye sida ngawbra gyan tabaga amta nang ngawbuga nang ogdri dura sir adudi ngawbu nang ogdri hena gyan tadabra
Tayo, sir.
taika
ꯁꯥꯔ
oh hero
ꯑꯟꯁꯔꯗ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ 1ꯁꯤ ꯇꯥꯏ
minus sign ja
ꯁꯥꯔ
okay okay network done have ne ko net total energy okay fine so work done the negative foi ko half kx square minus half kx square potential energy stored na half kx square ne work done na negative ne ko okay fine ai adugi minor mistake tum start togre so work done the negative foi bane akoi ngarang togi budo work done negative oiba and then kedoba na potential energy na positive oigadaba ko so potential energy stored to na half kx square haiba adu moina net work done na haibani na minus when lower ni ko so sigisi minus when lower ni aduga amaji budi adum yare kai gyan tabra gyan tabro
Tayo, sir.
okay
ꯇꯥꯔꯦ ꯁꯥꯔ
haiba ko lakshmi tabra
No, sir.
okay fine yare lakshmi ga sunanda ga ji voice se lakshmi gi phone daina sunandai tholakpa sunandai phone daina lakshmi tholakpa adain toira
Tawde.
tawdi okay
Sir.
okay yeah okay fine so yeah adudi ngasi giti koi sida loishalasi atopa noi question ke ka mayam ji noi dum angam bagai try toro very response in low conservation of energy blah blah collision ke ka lere then mathang ke wali collision lere loire ko so hayeng loire ni work energy power aduga hangsit tagi aina kaidoba rotational motion la adaina ko adugi iti tani ko so anyway ngasi gidi sida loishalasi ko everyone so noina khangdab khotaba ke ka lere sudum hango sir da ko anyway fine so thank you for the class everyone ꯂꯣꯏꯁꯤꯜꯂꯁꯤꯀꯣ
Thank you, sir.
Okay, fine. ꯂꯣꯏꯁꯤꯜꯂꯦꯀꯣ. Okay. Good night.